this ASCL problem called number transformation. In this video, I'm just going to explain the question and explain how I'm going to solve it, and then I will actually code it in the next video. So the point of the problem is that it will give you a very long integer that can be at most 16 digits called n, and then it will give you another smaller integer called p that is smaller than or equal to the number of digits of n. So what you need to do is count the pth digit from the left, so like 1, 2, 3. So here the pth digit is 4, and I'm going to call that number the axis number. So for all of the digits that are to the left of the axis number, you add the digit by the axis number and then take the last digit even if the resulting number has 2 digits. And for the numbers to the right of the axis number, you take the absolute value of the difference between the axis number and the original number. So the resulting digit will always be positive or 0 because it's an absolute value. So the easiest way to do this is to use and put this into an integer array where each element is 1 digit, and then just do what the problem tells you to, because this type of question is called an implementation question, where you don't really have to think about the theory of your solution, whereas in some other harder problems, you will have to do some math or optimize the immediately obvious solution so that your code doesn't go above the time limit. However, in this specific question, you just have to follow the instructions of the problem. So the issue with trying to use an integer array is that these digits are not separated by spaces. So if you try to input it as an integer, C++ will see this whole thing as one large integer instead of the individual digits that we wanted to see. So what I'm going to do here is use a string and then convert each character into a digit and then put that into the integer array. If you want to, you can also input this large number as a long, since the 10 to the 15th exceeds the maximum value of a C++ integer, and then probably use remainder to separate out the digits, but I'm going to use a string.